Hi, welcome back to another episode. We are going to continue under engines. We are going to talk about factors or terminologies that are used in describing the operation of an engine. Now, there are some components that we should make mention about that we are going to discuss before we delve into detailed parts or components that form the engine. Don't blink an eye. This is where you should be. My name is Abdurrahman Osman. I'm your instructor for MEL, Maintenance Engineers and Logistics. Before I continue, I would like you to know that we are into machine maintenance, repairs, rebuilds, fabrication, part sales, and more. Let's get back to business. As we talk about, some of the components we are going to discuss are 1, friction, inertia, force, work, torque, power output. When we talk of power output, we have gross power and net power. Now, the first thing we pick on is friction. You know, friction is a force that opposes motion. And in engines, there are sliding parts that slide on each other all the time. And when parts slide, friction is created. But then, we don't need friction in engines. We don't need friction. We need less friction. We know friction generates heat, and too much heat in the engine will cause another problem. So there should be a way of eliminating this heat when it's generated and also maintaining it in check, because there should be a certain amount of heat that is good for the working of the engine. Now, when heat is generated, how do we take? In the first place, we need to eliminate this friction, and we use lubricating oil to reduce the friction and to carry some of the heat away. The next thing we talk about is inertia. And we remember Newton's first law of motion, which states that a body continues in a state of rest or of uniform motion in a straight line unless acted upon by an external resultant force. Now, the phenomenon possessed by this body is what we term as inertia. Now, the inertia of a body is directly proportional to the mass or weight of that body. An example, we talk about the flywheel of the engine. As this engine turns, it has inertia, and this inertia helps maintain smooth rotation and constant output. The next thing we talk about is force. You know, force is a push or a pull that starts, stops, or changes the direction of motion of a body. Example, in the engine, force is created during combustion, which forces the piston down during the power stroke. Now we talk about work. Work is said to be done when a body moves its point of application through a distance against the direction of the force. Work is done when a force overcomes a resistance, create movement. The unit of work is the joule or foot-pound. The next thing we talk about is pressure. Pressure is a measure of force per unit area. The unit is Pascal or pounds per square inches. During the work of a 4-stroke cycle, pressure is created when the piston moves from BDC to TDC, compressing this air or air-fuel mixture. As this piston moves up, it compresses this air mixture, pressure is created, and when there is pressure, there is heat generated, and the resulting explosion creates more pressure that forces the piston down. Pressure can be created in 3 ways. 1, by heating. 2, by compressing a gas or liquid. And 3, by restriction flow, such as in the exhaust system. The next thing we are going to talk about is torque. Torque is the amount of twisting force placed on an object. A torque wrench, for example, places a twisting torque on a nut or bolt. Now, the twisting or rotational movement of the crankshaft is a form of torque. It can also be measured at the flywheel. Remember, torque does not measure engine speed. It's only a measure of the rotational force being applied. Engine speed is measured in revs per minute based on the number of times the crankshaft turns every 360 degrees per minute. The maximum torque of an engine may occur at less than the maximum RPM. This is due to the many inefficiencies that occurs at maximum RPM. Next thing we talk about is power output. Power is defined as the rate at which work is done or the speed at which work is done. So work done over time taken. Usually power output may be measured in two ways: gross power or net power. Gross power is the power output when the hydraulic pump, water pump, alternator, or air conditioning compressor is not considered. That is what we call gross power. Now, net power is measured at the flywheel after taking into consideration the water pump, the hydraulic pump, if it uses the alternator, or that of the air conditioning compressor. That is net power. But it doesn't take into consideration the power absorbed by the transmission system. This is it for today. Hopefully, tomorrow we continue with the next episode. Have a wonderful weekend.